Hello again, Year 10. This week we are going to carry on looking at quadratic equations. We are going to take the work that we did last lesson on completing the square and see how this process can be then used to solve a quadratic equation. However, before we get started, let's just wake up our brains with a little activity. Spend about 2 or 3 minutes on this, see if you can crack it. Can you put the numbers 1 to 7 in the circles such that each line, which is the two horizontals and there's two diagonal lines, no vertical lines, each line makes a total of 12? So can you put the numbers 1 to 7 in the circles such that each line makes a total of 12? Please pause the video here because I'm about to go through the answer. So the key to this was putting the number 4 in the middle. If you got the number 4 in the middle, there's various solutions, but this is one of them. Every single line adds up to 12. So on to today's lesson, Quadratics 10. If you've not been able to print out the note sheet to write on today, then I will be expecting today's date, today's title, today's objective in your book. There's a little bit of written sentences, but not too much. So we are going to be solving a quadratic equation using that process of completing the square. Now, the first thing that I just want to remind you is a quadratic expression can be written in the form x plus p squared plus q. This is called completing the square. And once you've done this, this is yet another way that you can solve a quadratic equation. Quite often in an exam, you might be able to use the formula, you might be able to factorize, you might be able to complete the square. So there might be a little bit of choice as to which method you use. I personally always favoured using the quadratic formula over completing the square. But sometimes it depends on how the question is set up. If in the first part of the question you've had to rewrite something in the form x plus p squared plus q, then it might make sense to then use what I'm going to explain today to go on to solve the equation. So it sometimes depends on the situation. So how do we do this? Well, it kind of links back to solving linear equations. If we have a quadratic equation that has been written in this new form, we can solve it using just inverse operations. And this is something that students quite often think they can do with a quadratic equation, but they don't already understand this idea of completing the square. So we'll see how this works through a couple of examples. Example number 1 says solve x squared minus 8x plus 5 equals 0 by completing the square. Give your answers to 2 decimal places. So remember, when we're thinking about the process of completing the square, it is rewriting that in the form of something squared with an extra number on the end. So remember the little rule. We look at the coefficient of x, which is negative 8, and we halve it, 4, and that is what goes in the brackets. We then need to consider what we need to add or subtract to make this expression equivalent to what we began with. So I quite often, and I'll do it up here, multiply out my squared. Don't know why I've put plus 4 because it is clearly negative 4. And I would get x squared, take away 8x, plus 16. So I have got positive 16 here at the moment. I need it to be positive 5 instead. So I need to subtract 11. So all I've done there is I've completed the square. Now I can use inverses to get x by itself. How would I do that? Well, I'm going to start by doing the inverse of take away 11, which is add 11. So I'm going to add 11 to both sides of my equation. I'm going to use my communication pen here, but you will see in the answers that I provide for you later, I will not have done these parts in purple. If I add 11 to both sides of my equation, the 0 becomes 11, and adding 11 eliminates this subtract 11, so I just have x take away 4 squared. What I will be doing next is the square root of both sides of the equation. And I can do that because all of the x take away 4 is being squared. So I will write this with a little square root symbol saying I'm doing the square root of both sides. Now this is where it's really easy to lose one of your answers, because when you do the square root of a number, there is a positive answer. That's the one we normally use, but there's also a negative answer. So super important today that when you do that square root stage, you put a plus or minus the square root of your number. On this side, I can just now get rid of the bracket, and I'm left with x take away 4. And if I want to get the x by itself, I'm now doing the inverse of take away 4, which is add 4 to both sides. So my final answer is plus or minus the square root of 11, and the inverse of take away 4 was add 4. And I've said give your answers to 2 decimal places. So this is where we're going to need our calculator. So using my calculator, I need to do the positive square root of 11. So I'm going to press positive square root of 11. I need to now click the arrow key for the mode that I've got it set up in, so the plus 4 doesn't end up being under the square root. Plus 4 equals, and you might recall my calculator is in a mode where it gives the answers in a slightly strange format, which we'll be talking about later this week. I'm going to turn it into a decimal, and that to 2 decimal places is 7.32. So one answer is x equals 7.32. So remember, to get my other answer, I need to do the negative square root of 11. So I'm going to press my negative button, square root of 11. Again, click my arrow key so I'm not doing my plus 4 under the square root. So again, just check what mode your calculator's in and turn it into a decimal. And 2 decimal places for that one is 0.68. So it is 7.32 or 0.68. Let's look at 2 more examples. So my second example says solve x squared plus 6x take 2 equals 0 by completing the square, but this time we're giving the answers to 3 significant figures. So let's go through the process of rewriting this by completing the square. So I know that in my bracket I need half of the 6. So it's x plus 3 squared. I know that x plus 3 squared, just do it over here, is x squared plus 6x plus 9. So I've currently got plus 9. I need to get back to negative 2. I need to subtract 11. So I've rewritten it in the form of completing the square, and I've got equals 0. Now I'm going to use my inverses. I'm going to add 11 to both sides. So I get x plus 3 squared equals 11. And that was adding 11 to both sides. Next thing I'm going to do is my square root. So when I do the square root, it's plus or minus root 11. And x plus 3. Just cancelling the squared. And then I need to subtract 3 from both sides, so it's plus or minus root 11, take away 3. So root 11, take away 3, equals... Remember, I'm doing 3 significant figures this time, so ignore the 0. So x equals 0.31. So that's 6 is another 6. That's 5 or more, so I'm rounding up. So 0.317. Let's do the negative answer. Negative root 11. Take away 3. And that is negative 6.32. The 6 making it round up. So those ones are 3 significant figures. I thought we'd have a look at one example where the numbers get a little bit nastier because we've got an odd number that's the coefficient of x. So let's look at this last one. We talked about in my previous video how we could do this with fractions or we could do it with decimals. I'm going to stick with decimals because I think more of you will like decimals, but remember I said I prefer to use fractions myself. So let's complete the square on x squared take away 3x take away 5 equals 0. Well, half of negative 3 is negative 1.5. So that's what my bracket looks like. But we need to do negative 1.5 expanded. And this would be x squared take away 3x. And 1.5 squared is 2.25. So how am I going to get that back to negative 5, which I need? It's minus 7.25. And that equals 0. So I've completed the square. I am now ready to use my inverse operations. So we're going to start by adding 7.25. So we end up with x minus 1.5 squared equals 7.25. And I will let you in on a little hint today. If this number here, when you have done your rearrangement and you're about to do the square root, is negative, you have gone wrong today. I don't know if you've ever tried doing the square root of a negative number on your calculator, but your calculator will give you a mathematical error. So for the time being, if you get a negative number there, you have gone wrong. Now I'm doing the square root of both sides. So I've got plus or minus the square root of 7.25 on this side and x minus 1.5 on this side. So x equals plus or minus the square root of 7.25 plus 1.5, adding 1.5 to both sides. Let's get our two answers using our calculator. So we've got the square root of 7.25 plus 1.5, and that is 4.19. Again, we're doing 3 significant figures, and the other one, the negative square root of 7.25 plus 1.5 is minus 1.19. So you might want to go back to my instructions because there are a few questions for you to try. Only 9 today. You'll notice that the last 3 are questions where the coefficient of x is an odd number. I'd like you to give all your answers to 3 significant figures today and just get as many of these questions done as you can. Don't forget to spend the last 5 minutes checking, correcting, marking your work with that different coloured pen, please. And as always, if you've got any problems, you may ask in the Ask the Teacher channel.